If you want to get at what's the sign, right? What's the sign of this with respect to this? That's one question. There's a whole other question, which is how does S affect this marginal utility? Now, you can see why UCS being positive isn't sufficient, right? Because what happens if I raise S at date t? Well, raising S at date t is going to give me a UCS here, but it's going to give me a bunch of USS terms going forward, right? And if USS is negative, so that the marginal benefit of S, if it's positive, goes down the more S I have, or the marginal cost of S gets more negative if it's already negative, then that's going to go the other way. That's going to tend to make these things substitutes rather than complements. So it turns out in order to get complementarity, that is to get it so past consumption reinforces future consumption, you need something stronger than UCS being positive. You need that UCS is positive, but sufficiently positive that it outweighs this USS term. That basically there's a negative built-in effect of rising marginal cost or diminishing marginal benefit. And that's the kind of condition you need in these addiction models. Now, what it turns out is these addiction models can be pretty strong. They can mean that if you make a plot, you might have a world that looks like this, where here's S, and then here's C equals delta S, right? So that's what? That's the steady state line, right? There's a steady state where C equals delta S. And then these addiction models give you some kind of like upward sloping C of S function. That is, the amount you consume can depend on the stock that you have, how much you've consumed in the past. And upward sloping is kind of almost like the definition of addiction. The more you've consumed in the past, the more you're going to consume in the future. So then what happens if you like change prices? Well, if you change prices, what happens is C goes up. So this is C0 bar. This is C1 in the short run. And then eventually you go up to here, C1 bar, right? So if you like lower prices, that'll shift this schedule upward. Call this C0 of S, C1 of S. And so what happens is you get this bigger long-run response than you get a short-run response. So that would be kind of like the classic addiction model. It sort of says if you reduce prices of the addictive good, people will consume more like they would for any other good, but then over time, they'll consume more and more as that reinforces itself, right? Because your S is going to go up, and that S is going to feed future consumption. Okay, this is where they're complements. CT and CT minus 1 are complements. There would be a dynamics. It's a little bit like what we had with capital in the neoclassical growth model, right? We had an impact initially of technical change, and then we reinforced that over time. All right? Now, you could also think about this as like, you know, the way we dealt with addiction, we made this S like unobservable. It was just a stock that was running around in the background that we couldn't measure directly. We could infer its presence by behavior, but we couldn't measure it directly. You could make S much more observable. Like you could, one thing you might say is gasoline is addictive, right? Why is gasoline somewhat addictive? What happens? Think about it. What happens when the price of gas goes down? Well, price of gas goes down, people consume more gas. But then they start buying less fuel-efficient cars and all that stuff, and then we work our way up to the new long-run effect. In that case, you might say S is like the stock of cars. S is an observable quantity in that case. S is the stock of cars. Now, it's not perfectly collinear with consumption, but nonetheless, it's going to behave in much the same way. Now, one thing that's interesting that can happen when you get an addictive good is these curves can be so upward sloping that you might have a picture that looks like this. So this is C of S. And this is C equals delta S here. Now, how is consumption going to behave in this world? Yeah, that is, if you start to the right of S star, then consumption is going to exceed depreciation, and you're going to move to the right. And if you start to the left of here, you're going to go down and eventually quit. Right? So that would be an example of what we call an unstable steady state. That is, depending on whether your stock starts above or below this critical level S star, you're going to go up, or you're going to go up if you start above, you're going to go down if you're not. So people might start out pretty similarly. One guy consumes a little more than the other guy initially, but over time, they're going to go further and further apart. Some people are going to go towards zero, while other people are going to go up to a positive steady state level of consumption. You can even build models where consumption grows forever, where you just keep consuming more and more forever. Now, that's kind of a bit unrealistic in the sense that, we don't really see that happen in practice, but you can certainly build theoretical models along those lines. All right? Yeah.